It took the world's most powerful laser and more than a decade of effort, but researchers in the US have finally done it. Their machine created a nuclear fusion reaction and crucially got more energy out of it than they had to put in.
Last week, for the first time, they designed this experiment so that the fusion fuel stayed hot enough, dense enough, and round enough for long enough that it ignited, and it produced more energies than the lasers had deposited. About 2 megajoules in, about 3 megajoules out, a gain of 1.5.
Fusion is the reaction that powers our sun. Finally proving energy can be made from it here on Earth is a major breakthrough for an increasingly crowded fusion field. There are several national projects and more than 30 private fusion ventures. This company in Oxfordshire says it's aiming to produce electrical power from fusion as early as the 2030s. This machine recently hit a significant milestone. It got to a temperature of 100 million degrees at the centre of the reactor. Now that's 6 times hotter than the sun. So when it's running, this lab in Oxford becomes the hottest place in the solar system. The swirling glow in the centre of their reactor is a plasma, super hot ions of gas, the conditions necessary for fusion to occur. Theirs is just one of many competing reactor designs, but the team here say its edge comes down to its world-leading magnets, needed to recreate the gravitational forces found in the sun.
The benefit that these HTS magnets deliver is the ability to generate extremely high magnetic fields and to operate at elevated temperatures that really make for an efficient and compact reactor. The smaller you can make a reactor, the more cost-effective it will be, and in the development phase, it means we can get there faster.
But the science challenges of sustaining fusion for months, not seconds, then converting that energy into electricity for the grid are so huge. Some other fusion scientists argue none of the commercial fusion ventures is likely to succeed.
They are a very long way away from being at the scale necessary to generate fusion power from their devices. And so in order to do that, you need to be at the scale of the ITER plant where we are today. And when you get up to those scales, life gets very much more complicated.
ITER, the machine he's referring to, is a publicly funded international collaboration that's building a power plant-scale fusion device. This route to commercial fusion is several decades away. Whether a smaller commercial reactor can beat this approach is very much an open question. But today, fusion science took a big step forward. Tom Clark, Sky News.